Hey guys, as you can tell at this point, we are not having a Zoom today, but I do want to go over the instructions and kind of give you a quick mini lesson of what it is you need to cover today. So we've been talking about sample space. We are done with sample space and moving on to what we were going to do for the last 2 days of this week before your quiz on Friday, and that is making predictions based on qualitative and then tomorrow quantitative data. Today, qualitative, we're going to spend some time really looking at verbal descriptions of probability and using those verbal descriptions to make predictions. Tomorrow, quantitative, be building some ratios and looking at how do I move and use that to my advantage to make predictions. So your learning target today is I can make predictions based on probability, qualitative data. Let's talk about what that means. Let's talk about what that means. So when we're looking at this, would you rather have bag A or bag B? I'll give you some time to think about that. Now, more than likely, most of you are probably going to choose bag B. And because if you look at the dollar amounts in each bag, you'll notice that there's only 120 of 8 in bag A, but there's 720s of 8 in bag B, right? So when we're thinking about this, I can predict that it's more likely I'm going to get money in bag B than I would be in bag A, right? I'm less likely to get cash here. I'm more likely to get none. So we're going to look at which making predictions kind of based off that continuum. So we're going to go back and look at that continuum. And so reminding us that, remember, 0% or 0 out of 8, right? Or 0 means that it's impossible to happen. It's not going to happen. Whereas the opposite end would be 100%, 1, or 8 out of 8. We know it's certain it's going to happen. Now, in between in that continuum, right, we say if it's equally likely, half, 50%, half and half, 4 out of 8, okay, we're equally likely to happen as it is to not. If it's less than half but greater than 0, we say it's unlikely. If it's greater than half but greater but less than certain, we say it's likely. So, like, what are we going to be doing with that today? So, for example, what if we were given, it says 80% chance of rain today? So, we can make a prediction, right? A guess that, well, it's probably likely that we're going to see rain today. We're pretty sure that we're going to see rain. Versus like a 20% chance, well, we're pretty sure that we may not see rain. And we do that all the time, right? That's real world. When we see it in the forecasts for outdoor events, like, well, 20%, it's probably not going to happen, so we can continue. Or 80% is like, well, we're probably going to get rain, so we might need to adjust our plans. And that's real world predictions. Okay. So that's like an example of what you guys are going to be asked to do. So a local flower shop is preparing some bouquets to be sold in the store. Each bouquet must have 13 daisies in them, meaning that when they make a flower bouquet, they are required to put 13 daisies in them. So bouquet 1 has 26, bouquet 2 has 13, bouquet 3 has 30. So if I'm going to randomly choose one flower from each bouquet, we're going to use this continuum to describe and predict the probability of it happening. So bouquet 1 has 26 flowers. Remember, 13 of them must be daisies. So 13 out of 26 is exactly half. So I can say that there's an equally likely chance. I can predict that it's equally likely for me to grab a daisy as it is not to, right? Because it's right there in that one half. Bouquet 2 has 13 flowers. Remember, if we're making a bouquet, it must contain 13 daisies. So if the bouquet only has 13 flowers, that means all of them are daisies. So I am 100% sure that if I picked the flower from bouquet 2, it would come out to be a daisy. So I am certain. I can predict that I will get a daisy. Bouquet 3 has 30. Well, 30, 13 out of the 30 would be daisies. And we know half of 30 is 15. So since 13 is less than 15, we could say it's less likely for us to pick a daisy as it is not to. And so that's kind of what you guys are going to be doing today. You're also going to see information like this. So what you're going to get is a table and some statements, and you need to determine which statement best describes a prediction based on what you see here. So you're going to see a lot of vocabulary, and the way that they're ordered really does matter. So let's look at answer choice A. A person is 3 times more likely to choose comedy over horror. So that's saying that comedy over horror, so more comedy than horror. So far, so good. Now, it is a difference of 3, but when we see 3 times, that means times 3. And so what this is saying is that if I took horror and multiplied it by 3, would it give me the number in comedy? And we know 12 times 3 is 36, so those do not line up. Okay, so let's take a look at answer choice B. A person is twice as likely to choose drama than horror. Okay? And so what that means is that, remember, order matters. Twice as likely, meaning that drama is more than horror. Well, right there, we already know that this statement is wrong, right? We know that 12 people chose horror versus the 6 that chose drama. Now, if these were flipped, where it says a person is twice as likely to choose horror than drama, this statement would be true because we know 6 times 2 is 12. But because drama comes first, this statement is false because it's not more likely to choose drama. They are less likely to choose drama. So let's look at answer choice C. A person is less likely to choose horror or drama, so or meaning to add, so 12 plus 6 is 18, than action. So is 18 less than 17? No. So this statement is also false. So meaning that the last statement is true. But let's go back and look at why. A person is more likely to choose. So is it greater to have a horror movie with comedy? So 12 plus 15 is 27. Or action or drama? 17 plus 6 is 23. So is 27 greater than 23? That's true. So that's the answer is D. All right, so that's kind of a quick rundown of what you guys are going to be expected to do today. So here is what you need to do. So on your Schoology page, which we're going to go look at here in just a second, you have a Desmos assignment that's kind of going to walk you through this a little bit more. Then you have a 3-question practice in Schoology. Yes, I only gave you 3 questions, so it should be completed today. If you finish everything, if you had not finished your list and tree diagram, SPURS, probability sample space, you need to do that as well. Don't forget to do the fundamental counting principle. And then once you're done with everything, I will see you guys tomorrow. Any questions, let me know. Let's go take a look at your Schoology page. So in Wednesday's folder, the link for the DES book is here, and your practice is here. Okay? Like I said, I will not be near my computer for Zoom, but I will be answering emails if you need me. Go ahead and shoot me a Google Hangout or send me an email. All right, guys, I will talk to you tomorrow, and let me know if you have any questions.